in today's lecture we will learn how to form numbers. Basically we are going to count how many possible numbers could be formed. So, in the last lecture we have learned how to form words, and today we will form number forming. Okay. So, before we go further, remember that whenever we form numbers, the default case is repetition allowed. Repetition allowed is the default and repetition not allowed is the special case. So, if repetition is not allowed, it must be mentioned in the question only. Okay. So, if it is not mentioned, if nothing is mentioned, you have to assume that repetition is allowed. Okay. So, now let us solve one easy question and then we will go back to the first question. So, here how many 7-digit numbers can be formed such that no two consecutive digits are same? No two consecutive digits are same. So, that means what do we have to do here? We have to make sure that two consecutive digits are different. So, how do we understand this? First we have to understand how many places are there, because we are looking for a 7-digit number. So, that means there are how many places? 7 places. We have 7 places and we are filling these 7 places. Now, when we are filling, what are the digits that we are using? Digits are not mentioned here. So, that means we have to take all possible digits. So, what are the total possible digits? There are total 10 digits. Starting from 0 till 9, there are total 10 digits. Now, let us go for the filling process. So, first we understood how many locations are there and then we understood how many available possible options are there. Now, let us go for the filling. Now, while filling, we can generally start from any location. Okay. So, you need not fill the first location only in general. That means we can start from last, we can start from the middle also, it does not matter. But because here if first digit becomes 0, then it is not a 7-digit number, it is a 6-digit number. So, first digit cannot be 0. So, intrinsically, indirectly there is one condition on the first digit. So, we take this as our top priority. Okay. So, how do we do it? For first location, how many options are there? 0 cannot come here. So, there are only 9 options here, right. Now, from here to here when we go to the next location. Okay. So, now here once if you fill the first position, you have to fill the immediate position, because the condition is in such a way that you have to take care of the consecutive digits. So, that means immediately the next option cannot be same as this digit. So, how many options are there? If we remove one digit from there, there are 9 more options. So, for second location there are 9 options. Now, similarly when we go to the third digit cannot match with the first digit. So, how many options are there? Again 9 options are there. Now, we will proceed with the same thing. So, how many total number of ways are possible? This 9 will come 7 times. Okay. So, the answer is going to be 9 raised to 7. Okay. So, this way we can perform the calculation. So, in general we can start with any location. Even when it comes to our earlier seating arrangement question, we can start with any seat. It can be first seat or the last seat, it does not matter. But whenever there is a condition, you have to follow that condition. Okay. Now, let us go for the first question. Okay. Meanwhile, you can make a copy of this. Okay. So, let us go to first question. So, how many 4-digit numbers are there in which digits are in ascending order and in descending order? So, here a particular number cannot be in both orders. Okay. So, ascending means values must be increasing, descending means values must be decreasing. So, a number cannot have both orders. So, that means this is actually 2 questions. Okay. So, this is one part which is ascending and this is the other part which is descending. Okay. Now, when it comes to these, so what is the, how many places are there? There are 4 places. So, 4 locations. And how many are the available options? Total 10 options are there. Starting from 0 till 9, there are total 10 available options. Now, how do we proceed with this? So, first I will take the ascending order. So, in ascending order numbers must be in increasing order, right. So, I will take two cases, this is ascending and that side is descending. Now, number digits should be in increasing order. So, now 0 is the least possible digit, correct. So, if 0 comes in the first place, then this will become a 3-digit number, it cannot be a 4-digit number. So, 0 cannot come in the first place, but 0 is the least digit. So, that means in all these ascending order numbers 0 cannot come at all. So, the number of options you have for the first case are only 9 options. Okay. So, remember that whenever 0 comes here it becomes a 3-digit number. So, it is violating our rule, but ascending order means number should be in increasing order. So, that means 0 if at all it comes, it must come in the first place only, but if it comes in the first place it cannot be a 4-digit number. So, 0 is completely out of options. Okay. So, we remove 0 and we form the number using the remaining 9 digits. So, how do we do that? We can do it in 9 into 8 into 7 into 6 divided by 4 factorial ways. Okay. So, this is which method? This is the macro method or directly permute method. So, in general we can fill 4 places in 9 into 8 into 7 into 6 ways, but among the available 4 factorial orders we only want one of them. So, we multiply with 1 by 4 factorial. Okay. Now, if we do this by micro or select and permute, how do we do that? Because we are forming a 4-digit number, we first select 4 digits, that can be done in 9C4 ways, and among those available 4 selected digits there is only one particular ascending order. So, we multiply this with 1. So, here what is this process? Selection of digits and then arrangement of digits. Okay. So, this way we can do the first part, which is the ascending case. Now, let us go to descending case. Now, when it comes to descending case, 0 cannot come in the first location, right, because numbers are supposed to decrease. Okay. So, if at all 0 comes, 0 will come in the last place only, right. Now, 0 coming in the last place is perfectly valid number. So, that means here 0 is allowed. So, total available options are 10 options. Okay. So, we can do it by macro as 10 into 9 into 8 into 7 divided by 4 factorial. But if we go by micro, it is just 10C4 into 1. Okay. By same logic, if you select any 4 digits out of this 10, there is only one descending order. So, we do it. Okay. Now, here if you recall this idea and this idea, the macro idea, in macro always we have to at least once give it a thought to the 0. Okay. So, when we are doing by macro idea, we have to think about 0, what happens if it comes, but otherwise in micro we generally can avoid thinking about 0 also. Okay. So, whichever is convenient to you, you can follow either macro or micro, but when it comes to macro you may have to get into the details of what happens if 0 comes. Okay. Come on, make a note of this. Okay. So, now let us go to next question. How many 3-digit numbers can be formed using the digits such that it is an even number? Now, here I am going to take the same question and I will keep giving different variety of conditions. Okay. So, just like the way we did in the last lecture, here also I am taking the first question, one question, and I will take all special cases. Now, here if the number is even, so what comes the condition on the number? The last digit must be an even digit, right, that is the divisibility rule of 2. Okay. So, that means here out of these 3 locations, which location has condition? The third location has condition. So, that becomes our top priority. Okay. So, now look at this, how many even digits are there? 2, 4, 6, 8, there are total 4 even digits. So, last place can be filled in how many ways? 4 ways. This is our top priority. Now, out of these 2 you can fill whichever first, it does not matter. Okay. Now, how many options are available for the others? If repetition is allowed, then all 8 options are available. nothing is mentioned in the question. So, naturally repetition is allowed. So, that means for the remaining there are 8 into 8 ways. So, total 8 into 8 into 4 is your answer. Okay. Now, this is the case where repetition is allowed and that is the default case. So, let us explore other case also, repetition not allowed. So, in fact, in all questions today I am going to consider both cases, but remember, if nothing is mentioned in the question, this is your answer. Okay. This is going to be your answer, but we are also exploring what happens if repetition is not allowed. Okay. Now, if repetition is not allowed, then still last location has 4 options only. Okay. But the other locations now will have limited options because one digit already has taken place. Okay. So, that means for first location, now how many options are there? 7 options are there. For this there are 6 options. So, the answer is going to be 7 into 6 into 4. Now, while doing this 7 into 6, you can fill the first or you can fill the second first, it does not matter. Whichever location you want to fill first, it does not matter, answer is going to be same only. Okay. Come on, make a note of this. Okay. So, now let us go to next question. So, here number should be divisible by 5. Now, same available digits, but only thing is condition is changed. So, when it comes to divisibility of 5, what are the rules? Last digit must be either 0 or 5, but 0 is not among the available digits. So, we have only one option for the last location. Okay. So, for this location there is only one option. So, there is only one way, and for the remaining it is 8 into 8. Okay. So, this is your answer and this is the case where repetition is allowed. Now, let us explore the other case also. If repetition is not allowed, then still last location has only one way, but the others now will have 7 into 6 ways. Okay. So, this way you can calculate the numbers. Okay. Let us go to a little tougher question. Okay. Here the digit in the middle is the highest digit. So, here if you look at the phrase, especially in this chapter and the probability chapter, the language is very important. Okay. So, here what is mentioned, the digit in the middle is the highest, which means that is the only digit which is highest. There cannot be 2 digits which are highest. That is what this means. Okay. The highest means that is the only digit which is highest. Okay. So, that means the middle digit must be highest digit. Okay. So, this is our target. This is highest digit. Now, other digits of course have to be lesser than this in terms of value, but other digits can be same or they can be different also. Okay. So, now let us explore this, let us try to calculate. So, I am going to take 2 methods here. One is I will observe case by case. What happens if middle digit is fixed? Okay. So, let me fix middle digit to be 8. Okay. So, if middle digit is 8, how many options are there for the other 2 places? If middle digit is 8, then other 2 have only 7 options available, right? Only 7 options available for the other 2 locations. So, that means in how many ways we can get that? For fixing 8 in the middle place, one way, and for filling the other 2 places, it is going to be 7 into 7, which is 7 square. Now, here if you recall, we are also including the repetition here. Okay. So, here in this case repetition allowed and repetition not allowed both are considered. Okay. Also, just let me clarify this point here. In the first case, when we allowed repetition, repetition not allowed counting is also part of this. Okay. So, whenever we say repetition is allowed, it becomes the superset, repetition not allowed is the subset. Okay. So, now that means this also has repetition not allowed cases. So, first I am doing the repetition allowed cases. Now, again when I fix middle digit to be 7, how many options are there for the other 2? There are only 6 options, right? They have to be lesser than 7. So, that means for the second case, when I am fixing middle digit to be 7, I will get 6 square. Now you understood the main logic. So next number is going to be 5 square and next number is going to be 4 square and so on, right. So we have to do it till the last case where 2 is coming in the middle digit. So that means the other 2 will have only one option, which is the digit 1, okay. So this way we can perform the counting. So what is the value here? This value is going to be, of course you know the formula. So n into n plus 1 into 2n plus 1, 2 into 7 plus 1, it is going to be 15 by 6, right. So here 1 2 will get cancelled and 1 3 will get cancelled. So 4 into 5 into 7 is 140, okay. So in this case we have included both repetition and without repetition also. Now if you want to count what happens if it is without repetition, in this case you have to go for a slight modification while calculating. So what is the modification? For fixing 8 in the middle place, it is one way. Now when it comes to the other options there, how many digits are remaining? 7 digits are remaining. So out of them you can fill them in 7 into 6 ways, okay. So this is the repetition not allowed case. So this way you can perform the counting, okay. Now let me take you through the other idea. Other idea is not by going case by case. So let me just use select and perform, select and permute, okay. So when we go to select and permute method, how do we do it? If you recall, there are only two cases. This first location and third location, they can be equal or they can be different. So when they are equal, how many total digits are available? How many total digits come in the number? Only 2 digits come, right. There is one middle digit and these 2 digits are equal. That is one case, and the other cases all 3 are different, okay. So first let me take this case where these 2 are same. Now that means I only need 2 digits to form the number. So middle digit is 1 digit which is coming only once, and the other 2 locations are same. So I need 2 digits to form the number. So from these 8 numbers I will select any 2 digits. In 8C2 ways I will select any 2 digits. Now out of these 2 digits there is one digit which is higher, there is one digit which is lower, right. So I fill the higher digit in the middle in one way. Now there is only one digit left which is the lower digit, that can be filled in both these locations in one way. So this will give me all cases where middle digit is different and other 2 digits are same, okay. Now I will take the all different digits. So if all 3 digits are different, that means I need 3 digits from here. So I have to select 3 digits in 8C3 ways. Now out of these 3 selected digits, there is one digit which is the highest. So place it in the middle, we can do that in one way. And now there are 2 digits which are remaining, but those 2 can be arranged in the 2 different locations in 2 factorial ways, right. So this is all different case, this is n digits same case. Now when you add these 2, it must be equal to 140 only, okay, it has to be equal to 140. So how do we do that? You just calculate it and just verify, okay. So of course it has to be 140. So here we have understood the main logic of thinking differently, okay. So that is exactly my style of teaching. So I make sure that you learn to think properly, okay. So now this way we can form numbers, especially when there is a condition like this where a certain digit is highest, certain digit is lowest, okay. Come on, make a note of this. Okay. Now let us go to next question, okay. So next question is even little tougher than that, okay. So gradually the level is increasing. Here we have to make sure that the number is divisible by 4. Now what is the divisibility rule of 4? Last 2 digits must be divisible by 4, right. So that means our main focus is on these 2 locations. This is our main focus. Now, to understand the main pattern, let us observe some pattern. Okay. So, let me list down some numbers which are already divisible by 4 and see how the pattern is there. Okay. So, there is 4 which is divisible by 4, there is 8, there is 12, there is 16 and there is 20, 24, 28, 32, 36. Now, there is a reason why I have written them like this. Here, if you check the last digit, it is either 4, 8 or 0. So, these are the last digits are the digits which are divisible by 4. Okay. Now, here these 2, 6 are also even digits, but they are not divisible by 4. So, there is a pattern here. What is the pattern? If the last digit is already divisible by 4, now the digit before must be an even number. Okay. So, observe these numbers, it must be even number. For example, 48 is divisible by 4. So, if last digit is divisible by 4, this location has to be even number. Now, if last digit is not divisible by 4, but it is still even, then that means the second last location must be odd number. This is what you have to observe. So, if 2 and 6 come in the last place, this digit must be odd. If 4 and 8 or 0 come in the last place, this digit must be even, or here it can be 0 also. Okay. So, but it must be even. So, this is the observation that you have to understand. After you observe this pattern, we can make 2 cases and solve the problem. Okay. So, let me make 2 cases here. So, case 1, where last digit is divisible by 4. Okay. So, that means what are the possible cases here? So, observe here, there is no 0. So, there are only 2 options, 4 or 8. So, for the last location, in this case we are going to take only 4 or 8. Now, again for the second case, here last digit is not divisible by 4. So, what are the options here? Only 2 and 6 are the options. Okay. So, now let us solve this problem from both point of views, repetition allowed and repetition not allowed. Okay. So, now let us say I go for the repetition allowed case. This is our default. Okay. So, there are basically 3 locations here. Now, last location is filled in how many ways? 2 ways. Now, if this is even, this also must, if this is divisible by 4, the second location must be even. So, how many options are here? How many are even numbers? 2, 4, 6, 8 are the even numbers. So, for this there are only 4 options, and for the last one there is no condition. So, it can take 8 options. Okay. Now, similarly, if I go for the repetition not allowed. So, still here also for the last location there are only 2 options. Now, we have already placed one even digit in the last location, and the second location also must be an even location, but there is already one even digit taken. So, now available option for this are only 3 options. Now, 2 digits are already taken. So, for this there are only 6 options. Okay. Now, let us go to the other case. So, here also it is the same thing. Okay. So, here repetition allowed, there repetition not allowed. So, for this location there are only 2 options, right, and this must be an odd number. So, there are 4 options for this, and first location has 8 options because it has no condition. Now, similarly here if I try, the last location has 2 options. Now, this second has to be an odd number, so it has 4 options. Okay. And this location is going to have now how many options? 6 options. Okay. So, this way we can perform the calculation. Now, to get the total number we have to of course add both of them. Okay. So, now here it is actually the same number. So, what is the total here? 8 into 4 into 2 into 2, right. So, it is going to be how much? 128. Okay. Now, what about the number here? So, here 6 and 2 are actually common. So, we can write this as 6 into add 3 and 4, it is 7 into 2. So, it is going to be 84. Okay. So, this way we can perform the calculation based on the situation. So, when it comes to the divisibility by 4, you have to know this pattern. If you have not explored this, then you may get stuck in the exam. It may confuse you because students generally panic in the exam if they do not get answer very fast. Okay. So, here I think I have helped you to observe the pattern here. Okay. Come on, make a note of this. This page also. Okay. Now, let us go to the next question. This is even more tougher than the earlier question, okay, but this is a very good question. So, here how many 3-digit numbers can be formed using the same digits such that it is divisible by 3. Now, when it comes to divisibility of 3, what is the divisibility rule? Sum of all 3 digits must be divisible by 3, right. So, here it is going to confuse you because there are so many possibilities and we want to add all 3 digits and check if that summation is divisible by 3 or not, right. So, here our main goal is to add the 3 digits and check. So, what we do is we play with the remainders. So, here there are these 8 digits. Now, I will divide all these 8 digits with 3 and based on the remainders I will group all of them. Okay. So, basically we want to form one 3-digit number so that sum of all of them is divisible by 3. So, what I do is I group all of them in a pattern like this. Okay. So, 1, 2, 3 is 1, 1, 2, 3, 4, 5, 6, 7, 8. These are the numbers, right. Now, there is a reason why I wrote them like this, because this first group gives remainder 1 and second group gives remainder 2, third group gives remainder 0. So, we can say that third group is 3k type, that means it is a multiple of 3. Now, second group is giving you remainder 2 when you divide with 2, when you divide with 3. So, it becomes 3k plus 2 type. Similarly, this first group becomes 3k plus 1 type, 3k plus 1 type, 3k plus 2 type, 3k type. So, when we divide with 3, all these 3 numbers give you remainder 1, all these 3 numbers give you remainder 2 and these 2 numbers give you remainder 0. Now, based on this type, I will make cases and solve the question. Okay. So, let me solve this question in a different page here. Now, there are 3 locations. Out of these 3 locations, all 3 locations can be multiples of 3, right. This could be one case. If all 3 locations are already divisible by 3, their sum is also divisible by 3, right. So, first case is all 3 are 3k type. This is my first case. Okay. So, let me first list the cases here, then we will go for the counting. Okay. So, now second case, two are 3k type, okay, and one more case, third case, one is 3k type and one more fourth case, no 3k type. Okay. So, no digit is 3k type. So, let us take cases like this. Now, when it comes to the second case, if 2 numbers are already divisible by 3 and you want to add all 3 of them and result must be divisible by 3, right. So, third digit must be divisible by 3. Okay. So, if there are only 2 3k type numbers, the other also must be 3k type only. So, this second case is actually a rejected case. Now let's go for the third case and observe what happens here. Okay. So here one digit is 3k type. Now other two digits if we explore. So let's explore from the groups here. If I take any one number from this group and if I take any one number from the other group, sum of these two is always divisible by 3, right. So if you just add the remainders, you will understand it. So when you add any one number from here and any one number from here, in the remainders what is happening, 1 plus 2 becomes 3. So the net result is going to be divisible by 3. So that means when one digit is already divisible by 3, the other two digits must come one each from each group. Okay. So that means the others must be one 3k plus 1 and other 3k plus 2. Okay. So this is about the other digits. Okay. Others must follow this pattern when one number is already divisible by 3, right. Now let us go for the fourth case. Okay. So if no digit is 3k type, then again let us explore based on this grouping. So if no digit is divisible by 3, there is still one possibility that if I take all 3 from the same group, then the number is divisible by 3, right. So if I take 1 3 times, 1 1 1, it is divisible by 3. 1 4 7 is also divisible by 3. Okay. So this number 1 4 7 is also divisible by 3. Similarly, 2 5 8 is also divisible by 3. Okay. Or 2 5 2 is also 2 2 2 is divisible, 2 5 2 is also divisible. Okay. So this way you can understand that if you take all 3 digits from the same group, then they are still divisible by 3. Okay. So that means this remainder is going to get multiplied 3 times. If you take 3k plus 1 type numbers 3 times, then remainders get added 3 times. So 1 1 1 will get added and again result will be divisible by 3. Okay. So I think I am explaining by both patterns, by taking the numbers and also by adding the remainders. Okay. So that means here all 3 must be of same type. Okay. So till now we have analyzed all possible cases. Now let us do the counting for all of them. Okay. So I will take two situations here, repetition allowed and repetition not allowed. Okay. Now repetition allowed is going to be our answer, but repetition not allowed is like byproduct. Okay. So now if all are 3k type, so that means we are filling 3 locations with only these 2 numbers, right. So there are only 2 options and there are 3 locations. In how many ways we can fill them? 2 into 2 into 2. So here the number must be 2 cube. Okay. Now when it comes to repetition not allowed, you have only 2 digits available, but there are 3 locations. Now if repetition is not allowed, there is no way that you can fill 2 places in all 3 locations. So 2 digits in all 3 locations. So that means this must be 0. Okay. Now let us go to the next case. Okay. So second case is anyways rejected. So for this case, if we do the counting, one must be 3k type, others must come from 2 different groups. Now every group has options here. So your first step will be to select the digits. Okay. So let me select one digit from 3k type, one digit from this type, one digit from this type. Okay. So in how many ways you can do that? Okay. So I will write the numbers here for your clarification. So 1 2 3 4 5 6 7 8. Okay. So from this 3k type group, there are only 2 numbers available. So in 2c1 ways I will select one digit, and similarly from the second group and from the first group there are 3 available each. So I will select one digit from each case in 3c1 ways. Okay. So 3c1 into 3c1 for both groups. Now that I have selected 3 digits, now remember each digit is coming from a different set. So definitely here repetition is naturally not occurring. Okay. So for both cases the number is going to be same. Okay. So till here I have selected, now I will arrange all 3 of them in 3 factorial ways. Okay. So now for here for this case also it is going to be the same number. Okay. So, it is going to be same here, which is 2 into 3 into 3 into 6. Okay. Now, let me take the fourth case here. Okay. So, no digit is 3k type, that means all must come from the same group. Okay. So, here also we have written. So, there are 3 digits available here and there are 3 locations, right. But I can also take the second group, it does not matter. So, first I have to select one group. So, to select the group it is 2C1, and now in that group I have 3 digits available and there are 3 locations. So, it is going to be 3 cube here. Okay. This is further repetition allowed. If repetition is not allowed, it is going to be 2C1 into 3 factorial, okay, because a digit cannot repeat here. Okay. So, that is it. With this we have performed the required calculation, we just have to add them and count them. Okay. So, let us just add and see what happens. Here it is 8 and here it is 9 into 2, it is 18 into 6, it is going to be 108, right, and here it is 54. So, the sum is going to be 170 here. Okay. Similarly, here this is 108, so 108 plus 12, it is going to be 120. Okay. So, this way we can perform the calculation. Okay. So, when it comes to divisibility by 3, of course, it is going to confuse you if you do not follow any systematic method. Now, this is the systematic method I am designing and giving you. Okay. So, also if you have another kind of question where you have to add and the sum is divisible by 3, then you are going to follow the same idea. Okay. So, for example, I will give you one question here. Let us say there is a set, okay, starting from 1 to 100. Now, your x, y, z, these 3 numbers are belonging to this set, and now I pose a question that what is the probability. Okay. So, you understand the basics of probability, right. So, what is the probability that x plus y plus z is 3k type. So, what is the probability that sum of these 3 numbers is divisible by 3. So, how will you do that? You do it by the same idea. Okay. So, this you explore as part of your homework. Okay. Come on, make a note of this. Okay, this page also. Also this page. Okay. Now, here I have just increased the complexity by introducing 4 digit numbers. Okay. So, how many 4 digit numbers can be formed using the same digits and divisible by 3? Now, what are the cases? Still the grouping is same, right. So, what are the cases here? I will just list down the cases and I am not solving the problem. Of course, you can solve it by following the same cases. So, one case is because now there are 4 locations. There are 4 locations now. So, first case is all 4 are 3k type. Okay. Now, let me write the second case. 3 are 3k type. Is it possible? Of course, not possible. This is rejected case. If 3 numbers are 3k type and the fourth is not 3k type, so it is not possible that sum of all of them is divisible by 3, it is not possible. Now, let us take another case. 2 are 3k type. So, if 2 are 3k type, the other 2 can come from the different groups. Okay. So, that means the one must be coming from 3k plus 1 and the other must be coming from 3k plus 2. This is AND rule. Okay. Now, if you take the other case, so only one is 3k type, then that means other 3 must come from the same group. Okay. So, then it is the OR, either 3k plus 1, all 3 are 3k plus 1, or all 3 are 3k plus 2 only. Okay. So, here that means all 3 must be same type. Okay. Now, let us go for the other case, which is no digit is 3k type. no 3k type. Of course, this is also now rejected, because if you take no 3k type and if you add 4 digits, okay, so no, there is a possibility, yes, there is a possibility, okay. So then there is a case here, okay. So here 2 numbers must be of 3k plus 1 type and 2 numbers must be of 3k plus 2 type. This is one beautiful idea, okay. So two digits must be 3k plus 1 and 2 digits must be 3k plus 2, okay. So there can be this kind of possibility here, and the relation between these two is AND, okay. So by making these cases you can perform the calculation and you can solve it, okay. Come on, make a note of this. Okay, so now let us solve a different type of question. So here we have to find sum of all possible numbers that could be formed, but here the number of digits is not mentioned. So let me fix this. So let us take this as 4 digit numbers, okay. So because if you just take how many possible numbers are there, there are of course infinite numbers, right. So then the sum is going to be infinity only. So let me fix the type of numbers. It is 4 digit numbers. We want to find sum of all 4 digit numbers which could be formed using these same digits. So how do we do this? So to do this, you need to first understand certain basics, okay. So we have to form a 4 digit number. Now what are the values of the locations here? You recall your school knowledge, this is ones place, this is tens place, this is hundreds place, this is thousands place, right. So that means if at all there is a number like this 5, 3, 6, 7, let us say there is a number like this. Now what is the value of this number? The value is going to be 5 into 10 cube plus 3 into 10 square plus 6 into 10 raised to 1 plus 7 into 10 raised to 0, right. This is the value of that number, okay. So that means if a digit comes, if a digit let us take it as 5, if 5 is coming in the thousands place, its value is going to be 5000. If 5 is coming in the hundreds place, its value is going to be 500. If it is coming in the tens place, its value is 50. If it is coming in the ones place, its value is 5, right. So we have to add these values. That is exactly the meaning of adding all digits, adding all numbers also. Now if you check the possibilities, if repetition is allowed, there are 8 raised to 4 possibilities, right, 8 raised to 4 numbers are there, and if repetition is not allowed, then 8p4 possibilities are there, right, or we can also write it as 8 into 7 into 6 into 5, okay. Now number of numbers itself are too much, okay, it is too big, so we cannot blindly add all of them, okay. So if it is let us say 10 numbers or something, you can still think of adding them, but even if it is 10 numbers, then adding them is going to be taking longer time than directly performing calculation using the value pattern, okay. So I am going to use this idea to perform the calculation, okay. So let me just take it to the next page. What are the available digits here? Available digits are 1, 2, 3, 4, 5, 6, 7, 8. These are the available digits, okay. Now how many locations are there? 4 locations are there, and each location has a value. Now let me take 5 as the digit, okay. So let us say I am taking 5 as the digit, okay. So here I am going to calculate it for repetition is allowed, and in the next page I will do it for repetition not allowed, okay. So now let us say I take the 5, okay. Now if 5 is coming in the thousands place, what is its value? It is 5000, right. So, it is 5 into 10 cube. So, that means I will multiply this with 10 cube, okay, because if 5 is coming in the thousands place, its value is 5000. Now, how many times 5 is coming in the thousand place? Those many 5000s will get added, right. So, I have to count how many times 5 is coming in the thousands place. So, for that I will fix 5 in this location, this thousands location. So, if I put an arrow like this, then that means that location has a condition, okay. So, this is fixed now. So, a digit is fixed in that location in one way. Now, how many are the options for the other 3 places? Because here we are allowing repetition. So, other 3 locations have 8 into 8 into 8 ways, right. So, this means the digit 5 comes in the 1000 place how many times? 8 cube times. So, when 5 comes in the 1000 place, its value is 5000, but 5 is coming that in that position for 8 cube times. So, overall value must be multiplied with 8 cube. Okay. So, I hope you have understood the logic here. So, what I have done is, if 5 is coming in the 1000 place, in how many ever numbers it comes, I am going to add all those values. So, I added all the values of 5 if it comes in the 1000 place. Now, similarly 5 can come in the hundreds place also. So, when 5 is coming in the hundreds place, its value is 500, but how many times is it coming? So, for that I have to fix 5 in the second location and fill the other 3 locations randomly in 8 cube ways, right. So, that means I have to just add 10 square here and put a bracket here, right, that is what it means, okay. So, if 5 is coming in the 1000 place, I added all possible values, and if 5 is coming in the hundreds place, also I have added all possible values. Now, go for the other possibility. 5 also can come in tens place. So, if it is coming in tens place, its value is 50, and how many times 5 comes in the tens place? Fix 5 in the tens place and randomize the other 3. So, that means 8 cube times 5 is coming in the tens place. So, that means we have to put one 10 here, right. So, effectively we have added 5 into 10 into 8 cube here, okay. Now, similarly 5 can come in the ones place also. So, if 5 comes in the ones place, its value is 5 only, but it is coming how many times? 8 cube times. So, 5 into 8 cube must be added. So, that means we are basically adding 1 there, okay. So, I hope you have understood the main logic here. So, if 5 is coming in thousands place, its value I have added, and how many ever times it comes? For every time I have added one 5000. So, similarly I did for hundreds place and also tens place and also ones place. Now, 5 is not the only digit which can come, right. 4 also can come, 3 also can come, 2 also can come, 1 also can come, 6 and 7 also can come in all these locations, because all digits are equally likely, okay. So, what is the meaning of the phrase equally likely? That means whatever are the number of ways of 5 coming, same number of ways will be there for 6 also, same number of ways will be there for 7 also, right. So, that means we have to add all possible digits here, okay. So, there is 8 also. So, this is going to be your sum of all numbers formed, that too 4 digit numbers, okay. So, I hope you have understood the main logic here, okay. So, let us just simplify this for 1 or 2 more steps. So, it is going to be 8 into 9 by 2, and here this is going to be 1111, okay, and there is 8 cube here. So, you can just simplify it or you can just leave it right there, okay. So, this way you can perform the calculation when it comes to finding sum of all 4 digit numbers. So, that means for any digit number you can follow the same calculation, okay. So, come on, make a note of this. Now, let us perform the calculation for repetition not allowed. So, in this case again we have possibilities of all 8 digits. And how many locations are there? 4 locations are there. Now, again same, now I will take a different digit. Okay. So, let us say 3 is coming in the thousands place. If 3 is coming in the thousands place, what is its value? 3000, right. So, that means we have to multiply this with 10 cube. Okay. And how many times 3 will come in the thousands place? Fix 3 here and randomize the others. Now, repetition is not allowed. So, that means 3 cannot come in other places. So, that means how do we do that? In how many ways? It is going to be 7 into 6 into 5. Okay. So, here repetition is not allowed, one location is already taken. So, when we go to the next location, one digit goes down. Okay. So, this way we can perform the calculation. Now, 3 can also come in hundreds place. If 3 is coming in hundreds place, the value is going to be 10 square, 3 into 10 square, and how many times it is coming? 7 into 6 into 5 times. Now, just follow the same process here. Okay. And if 3 is coming, then that means other digits also can come, right. So, that means because all digits are equally likely, we have to add all of them. Okay. So, this is going to be our required number. Okay. So, this way we can find sum of all possible any digit numbers. Okay. So, now here if you follow this pattern, if you understand the pattern, you do not have to remember the formula, right. In some books formulae are mentioned for finding the sum, but do not follow any formulae. That is exactly my fundamental rule of this chapter. In this chapter there are no formulae, there are only methods, there are only ideas. Okay. So, from the beginning if you are following my style of teaching, it is always focused on learning the methods, developing the skills, not remembering the formulae. Okay. So, learn all methods and master this chapter. Okay. So, with this I close today's lecture. So, I hope you enjoyed the lecture and the discussions. We will meet again in the next lecture with some more interesting such ideas. Until then, have a great learning day. Learning shall never stop.